So now we're going to take a look at exceptions in Java. And exceptions are basically a form of error handling. There are two basic principles when we talk about exceptions, that exceptions are thrown and then we catch them. So when a piece of code, finds an error, whether these are classes that are provided by Java or even user-defined classes, such as a file IO problem or an invalid number for a student, we will basically begin creating what is known as a try-catch block. The try, open brace, close brace represents a block of code. Within that block of code, any number, one or more of the statements may cause an exception to be thrown. Then what will happen is if an exception is thrown at that particular line, the code will jump to this catch block and say, is the exception thrown the same type as what I am trying to catch? And if so, it will begin to execute the code underneath that catch block. And we can string a few exceptions together. But let's take a look at how this works. So there are some common exception errors that you'll see if you start working with Java. There's a SQL exception if you work with databases, IO exception if you're working with files. We'll see another one shortly of array out of bounds exception error. So let's say we have a piece of code with a try-catch block and we do this line, which is basically for file input-output, and it could throw a potential exception. If there's a problem with this where the file, say, does not exist, an IOException will be thrown from this line, and the code will jump to this catch block and say an exception has been thrown. Does it match this type? IOException. If it does, it will execute the code within this block. What it does here is it creates an object called with variable e of type IOException, which has more information about the exception that was thrown. We could also have multiple statements that may throw an exception. In this case, we have another try block where this buffered reader line could throw a IOException error. But we also may have an array index out of bounds exception being thrown by this because we are accessing a point of an array that does not exist, the 24th location out of an integer array of 20. So what will happen is if an error occurs on this line, it will throw an IOException and it will look at all the try catch blocks and find the first one that matches, which in this case is IOException. If an error occurs here, which it does, it will throw an array index out of bounds exception. It will look at the subsequent and sequential catch blocks, find the one that matches, and then execute the code that is within it. At the end of a try-catch block or a group of try-catch blocks, you have what's known as a finally block. The finally block is very simple in the sense that it is going to get executed no matter what exceptions are thrown or not thrown. This is particularly useful when you are trying to clean up code. Say you want to make sure files are closed or database connections are closed or network ports are closed. And in general, it's a very good practice to have a finally block. Again, if the try throws an exception, it will go to the exception and then go to the finally. If the try block does not throw an exception, it will jump to the finally and ensure execution of that block of code. So, like we said, exceptions are really just a class. They are an instance of a class, and they extend the exception class, which actually extends another class called throwable. So if we don't really particularly care about providing any particular cleanup, we can actually do a little bit of a shortcut. We're using the same code before, and any one of these lines can throw an exception. It's the first and third line. And what we say is, if an exception is thrown, we just want to catch the general exception, and we say exception E. Because IOException and array index out of bounds exception error all extend exception, by us catching the exception class, or an exception object, it will go into this line of code. We do not have to worry anymore, and we can just handle the error very simply and then jump into the finally block. We don't need to catch the specific exceptions. We just need to ensure that we catch the exceptions that are based on the various subclasses. We can also generate our own exception if we wanted to. We could basically create a class called myException, which extends exception. So this would be a separate class that would be outside of rectangle here. And inside of rectangle, in this constructor, we're saying if length is less than 0 or width is less than 0, throw new myException. We're saying to create a new object of myException, which should be available similar to rectangle and square was before. And then we want to issue a throw so that when the object was created for rectangle r equals new rectangle with the two parameters here, say in the main function, if we had put in an invalid value, an exception would be thrown and then we would have to handle it. Finally, the exception class has methods that we can use. Again, the letter E is a variable, and we could basically use anything like ERR or EXP. But within the exception class, which again comes from the throwable class, and you'll see the code down here if you like what functions you can use, we could actually reference a couple of methods like print stack trace or get cause. So we might inside of the exception block say e.print stack trace to say, tell me what is actually going on so that I can see on the console what error you actually have. Now this is more useful for some of the other exceptions like IOException and SOLException. Within those classes, SOLException class and IOException class, you can find additional methods that will provide more detailed information about the error that was thrown. So if you like, you can take a look at the throwable class for the basic exception errors, and if another exception is thrown, you can look up that class in the Java documentation and find out exactly what methods are available for you to use.